Wastewater from olive oil production. Environmental impacts, treatment and valorization. This book, edited by Abdelkader Anouzla and Salah Souabi, is a collection of academic research that provides a comprehensive overview of the challenges and opportunities associated with olive mill wastewater, a major polluting byproduct of olive oil extraction, particularly in Mediterranean regions. The sources discuss the physicochemical characteristics and pollution load of OMW, noting its high toxicity due to organic matter and polyphenolic compounds, which necessitate various treatment strategies. A central theme is the transition from traditional, linear waste disposal methods, such as evaporation ponds, to circular economy models that focus on the valorization and reuse of olive mill wastewater and other olive byproducts. Authors explore numerous beneficial applications, including extracting high-value bioactive molecules for the food, pharmaceutical, and cosmetic industries, and using the waste for animal feed, biofuel, and soil amendments through composting, to mitigate environmental impact and promote sustainability. This book summarizes recent research on olive oil wastewater management, characterization, environmental impact, recovery, and treatment, as suggested by experts in the field. The book combines different chapters on the management of olive oil rejects using simple techniques with low investment and operating costs. The main focus of the book is diagnosis, impacts of olive oil waste, and regulations. The valorization of the margins and the olive waste. Wastewater treatment and recovery. Evaluation of investments and operating costs of treatment techniques. Shaped by experience, the authors present their view and approach to each focus area of managing liquid and solid waste produced by crushing units.
Okay, we all love olive oil, right? It's pretty much the heart of the Mediterranean diet, a staple in kitchens everywhere. It's that liquid gold we can't get enough of. But what if I told you it has a pretty dark secret? A massive environmental cost that's totally hidden from view. So yeah, let's get into it because this story starts with pollution, but it ends with a really fascinating twist of innovation. So get this. Every single year, the global olive oil industry churns out over 30 million cubic meters of toxic liquid waste. To put that in perspective, that is enough to fill 12,000 Olympic-sized swimming pools. It's a staggering amount, and it all happens in a really short window of time during the fall and winter harvest. And the ratio here is what's truly wild. For every 1 kilogram of that beautiful olive oil that ends up on your shelf, the process can generate up to 5 kilograms of waste. Most of this is a dark, acidic sludge called olive mill wastewater, or OMW for short. It's a huge challenge that's literally baked into the process of making one of our favorite foods. So what exactly is this OMW? Is it just some dirty water? Not even close. It's this super complex, problematic mixture that has been a real headache for producers and scientists for decades. But as we're about to see, its toxicity is actually hiding some incredible potential. Now, at first glance, you might look at this and think, okay, it's 83% water, what's the big deal? But see that 12% slice for organic compounds? That right there, that's the crucial part. That small fraction is what makes OMW so nasty to deal with. It's packed with all sorts of things, including a very special class of molecules that are both the problem and the solution. Let's just put that organic load into perspective for a second. This stuff is acidic, it's phytotoxic, which is a fancy way of saying it's poisonous to plants, and it can have a pollution potential up to 150 times greater than raw sewage from our homes. Yeah, so just dumping this into rivers or on land, it's an ecological nightmare. It just wrecks soil microbes and aquatic life. And that brings us to the main character in our story, polyphenols. You've probably heard of these. They're the very same compounds that we celebrate for their amazing antioxidant health benefits in good olive oil. But when they get concentrated in wastewater, they become super toxic. They're so good at fighting off microbes that they end up disrupting entire ecosystems. So in a way, they're both the hero and the villain of this story. As our source material puts it pretty bluntly, in this form, these compounds are highly toxic to plants and microbes. This is the environmental problem in a nutshell. The very thing that makes olives so good for us makes their waste so bad for the planet. But that's not where the story ends. Because those exact same polyphenols, if you can get them out and purify them, have these incredible properties. And this is where the whole mindset starts to shift. It's brilliant. What if we stop looking at these compounds as a toxic problem to get rid of and start seeing them as a valuable resource that's just in the wrong place? This is where the whole idea of a circular economy just flips the script completely. Instead of the old model, produce, lose, and throw away, the goal is to close that loop. It's all about transforming this nasty waste stream into something incredibly valuable, literally creating wealth from waste. So how does that actually work? Well, scientists have a fancy name for it, valorization, which basically just means adding value. It's kind of a four-step journey. You start with the polluting gunk, you figure out how to pull out the good stuff, those valuable polyphenols, then you use them to create totally new products, and you get closer and closer to a zero-waste olive oil industry. And the new products being developed from this so-called waste, they are genuinely surprising. Researchers are finding ways to use this stuff in fields you would absolutely never expect. It's a true treasure trove of possibilities. The recovered materials are being used to create everything from advanced fertilizers for soil and additives for animal feed to biofuels. They can work as natural preservatives in our food, get used in pharmaceuticals and cosmetics, and they've even been mixed into eco-friendly building materials like bricks. It's incredible. Okay, here's a really amazing example of why this is such a big deal. Soil with too much salt is a huge problem for farming all over the world. It affects about 20% of all irrigated land. But get this, research shows that extracts from this olive mill waste can actually help other crops tolerate that salty stress. So the waste from one crop could end up helping to save another. That's just an awesome synergy. So if this has all this incredible potential, what's the holdup? Why isn't this happening everywhere? Well, turning this amazing vision into a global reality means we have to get over some pretty significant hurdles on the road ahead. And yeah, the challenges are very real. The tech to extract these compounds can be expensive. Taking these processes from a small lab and scaling them up to an industrial level is a massive leap. In a lot of places, there aren't clear environmental rules for this stuff. And finally, the wastewater itself can be really different from mill to mill, which makes it hard to standardize the process. But the good news is, progress is definitely being made, and it starts right at the source. For example, the type of technology the olive mill uses makes a huge difference. Modern systems, like cold extraction ones, use way less water and produce less liquid waste to begin with, so that immediately reduces the pollution problem you have to manage from the get-go. And we're actually seeing this change happen out in the real world. Take Turkey, for example, one of the world's biggest olive oil producers. With government support and incentives, they've managed to help about 60% of their mills switch over to these more modern, less polluting systems. It's a fantastic example of how policy can really drive positive change for the environment.